Hello everyone, this is section 1.4 in which we talk about exponents. Well, first things first, we need to decide what we mean by an exponent is in the first place. And a little bit of a definition is in order right here. And so my first question is, in words, explain what an exponent is. And a little bit of terminology would be helpful right here. So we need to do a little something first. Before we start off, what do we mean by the exponent? Well, there's actually two pieces of any number being raised to an exponent. If we have this number that's a normal size number, and we write it this way, we call that part the base. And if we have a number written in superscript up at the top, that is our exponent, and we sometimes call that a power. So knowing that definition, what should we say? Well, an exponent is the mathematical shorthand for telling you how many times to multiply a number by itself. Any base, a, raised to an exponent n, is the number a multiplied by itself n times. For example, we know that if our base is 8 and our exponent is 2, then we might write that 8 squared is the same thing as 8 times 8. 8 repeated in multiplication by itself twice. The answer to that, of course, is 64. So let's evaluate here on a couple examples. Let's take and evaluate negative 2 to the 6 versus negative 2 to the 6. One thing you have to be very careful of when it comes to exponents is where a negative sign is. In the first case right here, if we say negative 2 to the 6, what does that mean? Well, the quantity negative 2 is being multiplied by itself 6 times. Well, this is where we have to account for where are those negative signs leading us. Well, remember, if we're multiplying a negative number times a negative number, we get a positive number. So right here, we're going to be multiplying a negative times a negative. That would give us a positive. But then in the next number, we'd get a negative again. Then we get a positive. Then we get a negative. Then we'd get a positive. In fact, we're going to end up with a positive value right here. And if we multiply by 2, it'll be 2 times 2, which is 4. 4 times 2 becomes 8. I'm going to write this underneath. I'll write it in a little bit of a lighter color here. 2 times negative 2 would be positive 4. 4 times negative 2 would be negative 8. Negative 8 times negative 2 would be positive 16. Positive 16 times negative 2 would be negative 32. Negative 32 times negative 2 is going to be positive 64. Now that's pretty good. We're just multiplying the 2 by itself as many times as we need to get to the result. Well, what about negative 2 to the 6? Well, because the negative is outside of the expression, remember that the exponent will only apply to the very last thing it's attached to. So this is equivalent to saying the negative of 2 times 2 times 2 times 2 times 2 times 2 multiplied by itself 6 times. So the result here will be negative 64. And my little drawing board has this tendency to connect lines that didn't need to be connected. So the result would be negative 64. So the negative sign, the placement of the negative sign makes a difference. And the only time we treat that negative sign as something raised to a power is if it is in parentheses. Well, here's 2 more that are inside parentheses. What's going to happen here? Well, in this case, we're raising it to an even power. So the result is going to be positive, and it will be the same thing as negative 4 times itself an even number of times. Negative 4 times negative 4 times negative 4 times negative 4. So when we multiply those numbers, not negative 9, that's 4. There's my pen drawing those lines that didn't need to be there. Darn thing. And as you can see, if we take negative 4 and multiply it by itself an even number of times, we're going to get a positive answer. 4 times 4 is 16. 16 times 4 would be 64. We multiply 64 times 4 one more time, and this is one that we should be able to pick out right away, is going to be 256. Now, on the other hand, when we take negative 4 and raise it to the third power, we're going to treat it as negative 4 times itself 3 times. Since it's an odd power, the result will be negative. And it will be the negative of 4 times 4 times 4. Well, 4 raised to itself, 4 multiplied by itself 3 times is 64. So our answer here would be negative 64. All right, let's look at a couple more where we mix things up. Let's take a 5 squared times negative 3 to the third. Well, 5 squared times negative 3 to the third, we handle each exponent individually. So we're going to take 5 squared and we're going to rewrite that as 25. Now, on the other hand, we're going to take negative 3 to the third, and since we've got a negative number in the parentheses and an odd power outside, we're going to get a negative number. Negative 25 will be multiplied by 3 to the third, which is 27, and it's going to be negative since it's an odd power. So it's 25 times negative 27. Well, if we need a reminder on how that works, let's go ahead and carry out the multiplication if we need to. 25 times 27, 5 times 7 is 35. Carry the 3. 2 times 7, 14 plus 3, 17. So we get 175, and then we're going to leave a blank space or a 0 here. 5 times 2 is 10. Carry the 1 here. 2 times 2 is 4 plus 5 more, that's 5. So we're going to get 675. Learn to read your writing here. And since it's a negative, we're going to get the result negative 675 as our result. Finally, let's take negative 3/4 to the third power. It's the same thing as saying negative 3 over 4 times itself 3 times. Well, we're going to actually take this to be negative 3 over 4 times negative 3 over 4 times negative 3 over 4. But when we handle the multiplication, we can really just treat this as the negative because it's going to be a negative number raised to an odd power. 3 times 3 times 3, that's going to be 3 to the third, divided by 4 times 4 times 4, that's 4 to the third. And as we've seen, 3 to the third is 27. 4 to the third is 64. And this is our solution.